Okay? So colligative properties. Take a look at your, what page are we on? This is page 9, okay? So what is a colligative property? These are actually something, guys, that we use all the time without even realizing it. This time of year, okay, we've got snow outside. More is, I guess, in the forecast. I don't think we're supposed to get a lot, but like the eastern part of the state, they're supposed to get hammered. Yeah, where Oneonta, where I went to school, I think they're supposed to get a ton of snow again after they just got like 30 inches last week. It's crazy. But let me ask you this. What's the purpose of us putting salt on the roads? All right. Alex? Right. So it's not, we think, it's to melt the snow or to melt the ice. Really, guys, what it's doing is exactly what Alex said. We add the salt there to lower the freezing point of water so that ice won't form. All right, to keep the roads clear so that we can grip on them and drive on them and all that stuff. All right, I'll just be honest, we do a whole lot better job of that up here than where I was because they wouldn't start salting roads until like 20 minutes before snow was going to come, and then there'd be all this ice. It was rough, okay? Now, I don't know if you guys have ever heard, well, we'll talk about more as we get along. I'll use that analogy. But guys, that's kind of what colligative properties do, all right? Basically, the more things you have in solution means the greater effect on the solution in terms of melting point, boiling point, and vapor pressure. Those are the three colligative properties that we're going to talk about. All right. So really, what they're doing is they're these properties that are affected by the number of particles in solution. That's what a colligative property is. Okay. So if you want to kind of jot that down as a definition, they are properties that are affected by the number of particles in solution. What's an electrolyte? This is vocab, coming up tomorrow, kind of finalizing the last bit of vocab that we haven't talked about or used in this unit. What's an electrolyte, guys? Just from everyday use.
It becomes an ion in solution.
Okay, so it's a substance that becomes an ion in solution, and then what does that allow it to do? Have reactions occur? Maybe. Yeah, there's part of that. Electrolyte.
Electricity.
That's the answer. How did you write that on your read exam? I don't know if you can put a sound clip in there, Jill. Yeah, conductivity, right? So guys, a charge can now pass through. Electricity can flow through that because of the ions. So that's what an electrolyte is. We have strong electrolytes, weak electrolytes. We'll look at those a little bit more in our next unit. We do acids and bases. I've got a little demo that I'll show you. We'll test out to see if Gatorade really does have electrolytes in it, or are they just kind of full of it and telling you that it is. Okay, we'll test that out. Why would electrolytes be better at affecting these properties than non-electrolytes? Garrett?
Because they have a charge.
All right, it's not just that they have a charge. Okay. You just have a regular question. Hang on. I'll come back and answer your question in just a second. Why, guys? Why do you think electrolytes would have a bigger impact? It goes along with a charge, but what does a charge mean? If you have a charge, what do you have present, guys? Electrons or protons, but what do you say, Maddie? Ions. Guys, that's why electrolytes conduct electricity, is because they have ions present. Right? They've either gained or lost those electrons, and we now have ions. So non-electrolytes, they will still have some impact on these colligative properties, the melting point, the boiling point, elevation, all that stuff, but they're not going to have as big of an impact. Why? Why do you think that? Okay, they still will dissolve, but they don't form ions. They don't form multiple particles. And we'll talk more about what that means in just a second. Okay? Which of these, and what I mean by better, is which would have a bigger impact on either raising the boiling point higher or lowering the freezing point lower? Okay, those are two of the three properties that we're going to talk about. So take a look. We've got C6H12O6. What is that? Glucose, right? It's sugar. We have NaCl. What type of compound, folks, is glucose?
Covalent.
It's covalent. Right? So sugar is covalent. NaCl is Ionic. So guys, ionic means when it dissolves. If we were to write the reactions out that we've been doing, C6H12O6, all right, and we make that into an aqueous solution, we mix it with water, it's just going to look like this. Okay? You're just going to have that mixed with water. It will dissolve, meaning it's not going to be a solid anymore, but will ions form? No, because does it have ions that make up the compound? No. All right? It's a structure that's more, held together. There's no charges involved. Where salt, if we take solid sodium chloride and we mix it with water, we're going to get sodium ions plus chloride ions. Okay? So if we take a look, guys, if we have 5 molecules of sugar dissolved in water, how many particles of sugar would you have? Don't overthink it. 5, right? Because look at it. This is based on 1. All right, 1. It's a 1-to-1 ratio. So with covalent compounds, they're not splitting up when they dissolve. They're staying together. Another way to think about it is like this. All right, so I've got C6H12O6. It's staying together with water molecules all around it. Okay, but it's dissolved. It's mixed with the water at the molecule level. Right? So it's not just together with just sugars bound up. Okay? Where salt, on the other hand, it makes how many sodium ions? Look at your reaction that I wrote up there. How many ions formed? How many sodium ions formed? 1. How many chloride ions formed? 1. So a total of how many particles? Now, think about what the question's asking. It says if you have 5 formula units dissolved. Okay, I actually did this wrong. I wasn't thinking because I was trying to turn on that boiling water back there. 5 formula units, guys. How many sodium chlorides would I have? So if I had 5 moles of it, how many sodium ions would I have? 5. And how many chlorines? So I'd have 5 and 5 for a total of how many particles? I have 10 particles, twice as many here as I did with the sugar. So they're both going to have some effect. They're both going to lower the boiling point some. Okay, but one's going to be better. Which one would be better? Why? Because it has ions. It's got more particles that will be dissolved. That's why we don't use sugar on the road. Now, why else wouldn't we use sugar on the road, guys, in the summer? Everything's going to be sticky, right? Okay, obviously that's, we don't want that to happen. But if you think about the science behind it, guys, we use salt because there's more bang for your buck. There's twice as many particles because of those ions that are splitting up. Okay, so the visual that I want to see, these are the 3 colligative properties, guys. Vapor pressure lowering, freezing point depression. What does depression mean? What are you doing to something? You're lowering it, right? You're making it go down. So it's vapor pressure lowering. What that means is when we put salt on the roads, water, instead of freezing at 0 degrees Celsius, now it might freeze at -2 degrees Celsius. So like 32 degrees Fahrenheit, maybe now it freezes at 28 degrees Fahrenheit. Okay? By adding some salt to it. So that means, hey, if the weather's going to be cold, like 30 degrees, we'll put some salt on there, so now we have a better chance of the roads not freezing. Okay? Boiling point elevation, what does it mean to elevate something?
Bring it higher.
Right, you raise it. So on the flip side can happen. If you cook pasta, does anybody add salt to the water while they get it to boil, right? Now, part of that's going to be a little bit of flavoring, but if you added enough, you could actually make the boiling point go from like 100 degrees Celsius to like 103. What's that going to do for the cook time of your noodles? It's going to make it go down, right? Because they're going to cook faster. They're cooking at a higher temperature. All right? So these are the different effects that they can have and why they're so important for us. Yeah, exactly. So, guys, if you take a look here, you have pure water here on the left, okay? So a lot of particles will be able to escape. This is vapor pressure, okay? Where water's always evaporating. Particles are always escaping into the gas phase. But as soon as you start introducing something like glucose or sodium, okay, now you have other particles in that solution. Take a look at what happens to the number of particles, guys, that can escape into the gas phase. It's less. So your vapor pressure gets lower. Why? Because these other particles are taking up space at the surface. There's not as many water molecules at the surface level that can just escape. They're now layers down, so it's less for it to get in there. Same idea with the boiling point. Because you have more things in there, it now makes it boil or freeze at a lower temperature, and it takes more energy to get it to boil because those particles are taking up space. All right, so it all comes back to that KMT unit that we did a couple of units ago about volume and pressure and all that kind of stuff. All right, so which would dissolve the fat? Granulated sugar. Why will the granulated sugar dissolve faster? Yeah, more surface area, okay? And that relates to the physical state of the solute. So something like a solid versus a liquid, guys. A liquid is going to dissolve, or if it's broken up and granulated, all right, more surface area. Effervescence, that's what we just saw. So this is in relation, guys, to your vocab quiz tomorrow. What is effervescence? This is just kind of a review. It's a vocab. I want to hit the last couple of vocab terms before the vocab quiz tomorrow. What's effervescence? You all should have definitions.